Hello class, welcome to 4.3a, Measures of Dispersions and Box and Whisker Plots. Just a few things we want to clarify before we start talking. When we start talking about measures of dispersion, a couple things we'll be looking for is a min, or that would be your minimum, which will kind of represent your lowest number. We got your max, or of course your maximum, which would be your highest number. And then we need those two numbers to find your range. So the range is just kind of your measure from the highest minus the lowest. And of course, we've talked about median, which is going to end up being our middle number. And then these other ones, the lower quartile, that would be the median of the lower half. This is going to be represented by a Q1, as we talk about this one later today. The upper quartile, that's going to be your the median of the upper half, which would be represented as a Q3. And then what we're going to talk about is your interquartile range, which would be the upper quartile minus the lower quartile. And then lastly, we're going to put all these into a box and whisker plot, which is a graphical representation of displaying variation. Comparing measures of central tendency with measures of dispersion. So when we following the following data represents the bowling scores of 8 students. Find the mean, median, mode, and range of the data. So a lot of problems we're looking for is going to ask for all 3 of these. So this is where we need to take a minute to plug in these into our list, and then we want to be using that one variable stats. So as you plug them into your list, confirm that we can get the answers below. And if you remember back to the last lesson, when we start looking for the mean is going to be your x bar. Where does that x bar come from? That was with your sigma x divided by n, which is really just telling us the sum. So we have that 976 divided by the 8 values, and it's really going to tell us that this is equal to 122. When we look at our median, we have to scroll down through, find our middle value, and that was 111. Our mode comes from our most often, and that's where we're looking for 104. Now the only new one here is going to be our range. Now we could find these if we look at our min values, our max values, and we could look at just these numbers, say, well, what's my smallest number, and find 104. What's my biggest number? 189. But just take a look a little closer at our one variable stats. It is going to find those values for you as well. So when we look at our min max, make sure they match up. And when we talk about range, it's really just your biggest number minus your smallest number, and then do our subtraction. Because what the range is going to tell us is just a distance, or just a number that represents from your lowest to your highest value. Basically showing us that it's, 85 apart from the minimum value to our highest value. So, should that range be used to represent the score? Why or why not? Well, think about that for a second. If we were trying to represent the scores, does 85 represent anybody's bowling score? No, not really. So we would not want to use that, simply because all that's telling us is the difference between the highest and the lowest. All this is doing is, when you talk about range, is talking about how far apart your best to your worst player were, or when you do them. So in general speaking, the measure of central tendency are going to be used to summarize your data. In other words, replace it. So we're taking all of those numbers and just replacing it, or taking the summary and say, well, on average, we talked about all these things that just represent the middle, the average. So we would be able to say, all right, the middle is about 122. Or if we use the median, we're going to say it's 111 if we want to get rid of that 189 outlier. Where the measure of dispersion is going to be used to describe the spread in the data. So it's kind of just figuring out how consistent are these numbers. So if we have an 85, that's telling us that's a pretty big gap of scores, anywhere from 104 to 89. That's 85 different scores in between that these people could be bowling. Now, if everyone was a little bit more consistent, we'd see something much smaller. Like if everybody was in the 120 to 130 range, well, that's only a range of 10 if we do the 130 minus 120. So it's really to kind of just give everybody an idea of how consistent is this data. All right, let's look at some more examples. Okay, example 2 is going to be creating a box and whisker plot. So before we talk about how to, or actually creating it, we need to know a few things. There are 6 things that we are going to want to have to create your box and whisker plot. We're going to need the minimum value, the lower quartile, the median, the upper quartile, the maximum, and a number line. So when you look over here at the example, you will see in your calculator, if you paid attention to that last slide, we have the min x. That is something your calculator is going to find. Q1, that's going to be talking about our lower quartile. We're going to have the median, which we've been working with. And now we're going to have a Q3, which would be your upper quartile. And then we have the max, which would be your maximum number. Now we are going to want to have those 5 things from our calculator. And then we also just need to make sure we have a number line to work with. So when we do this, another thing we want to watch out for is when we talk about the median, what that's doing is splitting your data in half. So if you go from your max, right, when we kind of lined them up, that's basically breaking this down into 50% from your median, from your upper half, and your lower half, which is where we get this lower quartile and upper quartile. Now, when we go in here and break this down even further, when we talked about the definition of a lower quartile, that was the median of your lower half. So now we're taking this here, and we're going to find that median. That's going to be your Q1, which is going to break down basically our graph into the lower half into 25% and 25%. Where if we look at this upper half, that is also going to be split in half by another median. And that is where our Q3 or our upper quartile ends up. So what that really is telling us about this graph is between 15 and 17, and we go from here to here, that's 25. That is like the uppermost section. Top 25% are in 15 to 17. Then we're going to be looking at from about the just slightly less than the 11 to 15. That's going to be 25%. Between a little bit less than 9 and a little bit less than 11, that would be 25%. And then we'd also be looking at the 25% between that minimum value, which looks to be about an 8 to a 9. So what that means is that that information is going to be needed to kind of interpret some questions. So as we just talked here, because of how this box and whisker plot is created by breaking it down by median, this is going to tell you that there is 25% of your data in each section. All right, so let's kind of expand out here and take a look at example 2. So the first thing we're going to need to do is take a minute to pause and put all of these numbers into list 1. That way we can go into our one variable stats, and we're going to collect those 5 things we need. So take a minute to pause and do that now. So we should end up, after we do our one variable stats, we will need to scroll down so we can find those 5 things we're looking for. and they're going to be right at the bottom of that information. So you can see here, without having to do too much hard work, we are going to break that up. And now we got to take a minute to just kind of do our number line. So the one thing we want to look at here is, again, just like we were doing our graphs, is we have a min value of 2 and a max value of 80. That's going to be important to kind of realize that we need to count from 2 to 80 on this number line. So we probably don't want to count by ones. This might rely on us doing something counting by tens, and then we'll just kind of have to estimate those numbers, maybe even 5. I'm going to count by tens here, so let's take a minute to do that. Okay, once we have our table set up as evenly as possible, obviously going to be a little imperfections with you hand draw, but at this point we want to start dissecting each of these values like we did above. The first thing, it doesn't really matter where we start because we have all of these values here, but if we know that min value is 2, that's going to start here. And you know what, just for these first couple, we'll kind of label each of these key points. We know our Q1, or our lower quartile value, is going to be a 17. So that'll be about right here. We know our median is about 34.5, so that's going to be about right here. And I'm leaving some space above because we got to come back and put our box and our whiskers in there. We got our Q3. Let's find that. That's about a 59 right about there. And we know our max value is out to 80. Now, if you look at how we drew that above, a box and whisker plot has just basically the box on these middle numbers. So we're going to do our best to just draw a nice little box. And then our whiskers kind of extend out to those min and max values. So there it is. Okay, now we can, like I said, we're going to just identify those points. The middle should be the box. We got those whiskers. And then that's going to allow us to kind of set up for some of our questions. So, the interquartile range. The interquartile range is going to be found by finding Q3 minus Q1. Because what that's going to ask us about is, what is that middle, essentially, what is that middle 50%? Where is our middle 50%? Because if you think about that, right, we've been saying like each one of these sections turns out to be 25% of your data. So if we look at that, well, what was our Q3 value? 59. What was our Q1? 17. So if we do 59 minus 17, that's 42. So what that's going to tell us is over half of our data is spread out amongst a range of 42. So that's a pretty big range. Okay, looking at our next question. Where are we going to find the greatest 25% falls between which two numbers? Well, like we've been saying, right? Each section is 25%. Well, where are our greatest 25%? That goes here from that 59 to that 80. So 25%, our greatest 25% is between 59 and 80. And if we look at this and say, how many values are in each section? Well, we've got to think a little bit about that and say, how many numbers were in this values here? All right, looking over here at our graph, let's see if I don't know if you saw me circle that. There was 12 in all. So if we have 12 total, we are breaking it down into 4 different sections. 12 divided by 4 means there are 3 values in each section, respectively. Okay? All right, let's take a look at example 3. Okay, example 3 gives us a box and whisker plot and wants us to answer a few questions. Well, using what we did in the last example, label the graph with the min, max, Q1, Q3, and median. So, your min value, right there, That looks like that's going to be a 2. Check. Our max value, well, that's going to be way over here. That looks like it's about a 20. Check. Q1, that is the middle of our lower half. So that right over here, that's going to be our Q1 value. And that looks like that's probably a 4. Q3, that's your upper quartile. And that looks like it's going to be a 14. And our median, right down the middle, looks to be an 8. So, as we kind of like checked them off and labeled them, that's going to help us answer a few of these other questions. What is the value of the median? Well, look up there. Right down the middle, that's an 8. Our range, remember, that is going to be your max minus your min. So that's going to be 20 minus 2. That's 18. The greatest 50% lies between which two numbers? So again, we got to think back that every section is 25%. So if this is 25%, this is 25%. That makes up our greatest 50%. So that looks like that's going to fall between an 8 and a 20. The interquartile range, this was Q3 minus Q1, because what that's trying to find, again, is going to be that middle, pretty much your box area. So if we do Q3 minus Q1, that looks like 14 minus 4. So that's going to be a range of, interquartile range of 10. If there are 60 numbers in this data set, how many of them are in each section? Well, if there's 60 of them, and we split that up into 4 sections, 60 divided by 4 would mean that there are 15 pieces of data in each section. Okay, let's look at example 4. Example 4, basically looking at our box and whisker plots in the real world. Taking a look at saving the coral reef. I don't know if some of you have heard about that or not, but just to kind of read through that, the Great Barrier Reef is basically, a huge home to many different species of fish, whales, dolphins, turtles, birds, mollusks, all sorts of stuff. But the problem is, as you look at this graph, what do you notice? What do you see happening here? Just think about that to ponder before we talk about it. If we look down here in 1985, well, what do you notice about our median? We're looking up here at maybe our highest percent there. We start looking at how this is going as the years increase. Now we got a couple outlier type, pieces to this graph. That's what these little circles outside of our norm. This would represent some of those outliers that might have just came in as a little bit higher than what you would really expect there in those years. But what do you see the general pattern of this work? As our median keeps going up this year, it looks like it is almost doing, if try to draw a little line in there, it almost looks like it's trending to get smaller and smaller. Our highest values are trending smaller and smaller. So when we look at the coral cover, we can compare year to year over a course of time, just trying to keep those, average measurements, trying to figure out where that data is falling. And we can kind of track how this coral reef is kind of essentially decreasing its coverage over the years. Which, with all of this data over here with the fish and whales, dolphins, turtles, species, birds, that's why you're going to see such a huge push in some environmentalists to, essentially try to save this coral reef. All right, just a little fun look at where these come. You will have some other assignments, so make sure you check into Canvas for those. Good luck. Have a nice day.